Hello everyone, welcome to my presentation video of a project that I have been working on recently. It's about a 3 degrees of freedom planar robotic arm. I hope you enjoy it. So this is the robot. It's a 3 degrees of freedom planar robotic arm. As you can see, it has 3 servo motors that are attached to the joints of the robotic arm, and this will provide movement in all its joints, right? And with this we can reach a certain position in the Cartesian system that it's drawn in this cardboard that you can see here in the image. Now I will explain you the design of the system that I developed. It is based on an MQTT network, which is a communication protocol that is widely used in IoT applications. First, we start with a Python program, which is the main interface between the users and the system. Here the users basically can just input the desired position that they want the robot to reach. In this case is input as a coordinate, an X and Y coordinate, and well, it requires more information that I will explain later. But at the end of this program, we will get values of angle, triangle values for each of our joints. These angle values will be stored in a JSON file that will be sent through the MQTT network. So here we are using what we call topics in MQTT, which are kind of communication channels where we can send data. Our Python program, what it does is to publish in this topic, and it will be publishing the JSON file with the angle values. And then a third element, which is a broker, will manage these messages that are being sent in this topic in order to send them to those devices that are subscribed to the topic. In this case, the device that is subscribed to this topic is the microcontroller ESP8266. The ESP receives the data in JSON, it processes the data, and it basically sends the angle values to our servo motors in order to start moving our robotic arm and reach the desired position. So I will give you a brief explanation of Python control software. First, it starts and it prompts the user for an XY coordinate and also for an alpha value. Then it prompts you from which type of motion you want the robot to have, angular or linear. And depending on this motion type or this trajectory type, the program will compute a different set of calculations. Once the position is reached, it will prompt you if you want to move to another position or if you want to quit the program. So that's basically it. Here are the inverse kinematic equations that are used to transform the coordinates that the user inputs to angle values. So I mentioned before that the user inputs an alpha value in our Python program. As you can see here in the inverse kinematic equations, we have this alpha value. If you look at the diagram that is in the left part of the presentation, you will see that the alpha value is drawn in the end effector, or like the farthest point of our robotic arm. This alpha value is an angle of the position of the third link of our robot, and it's a position that is related to the x-axis of our Cartesian coordinate system. This alpha value is used to reduce the amount of solutions that our inverse kinematic system can have, because we can reach a specific position in our coordinate system in many ways. So in order to reduce the amount of possible positions that we can have to reach a coordinate, we have to use the alpha value so we can be able to actually compute the inverse kinematic equations. And well, these are the equations that are used to calculate the linear and angular trajectories that are the ones that will take us to our desired position, right, in different ways, but at the end we will get to the same position but with a different type of trajectory. And finally, well, the data is sent in a JSON file from our Python program, and it travels through the internet to our ESP8266 microcontroller. In the microcontroller, what we do is to connect to the internet and to our MQTT network, and we subscribe to a specific MQTT topic to receive the JSON data from our Python program. Then it decodes the JSON data and it gets the angle values that are sent to our servo motors, and this is how we control the motion. Now I'm going to give you a brief demonstration of how the robot actually moves. It will be a demonstration with angular and linear trajectory, so you can spot the difference between both of them. Well, we are back. I hope you could spot the difference between linear and angular trajectories. As I shown in the videos, the linear trajectories goes from point A to B following a line, whereas the angular trajectories follow like a more curvy or angular motion to move from point A to point B. And that's basically it. I will leave in the description my GitHub account with the link to this project, so you can download the Python code and also the Arduino code that is used for the ESP8266. I mean, if you are curious about building your own robot. But for now, this will be the end of this video. As future work for this project, I would like to create a computer vision software with the OpenCV library to control the robot with a camera, so it can reach different figures from different colors. And well, of course, I would like to redesign the robot and enhance its design to improve the precision, since the one that I have right now, it's not of the best quality, so it definitely needs some changes in order to enhance the precision of the movements. So this is everything. Thank you so much for watching.